assignment that we had yesterday. So let me share the screen and show the assignments. What we will also do is take some sample submissions and discuss them in brief. So I'm sharing my screen and showing the spreadsheet which lists down the submissions. So we have had 20 submissions, 20 children have completed the assignment. So thanks to all the 20 of you who have taken the effort. What you submit is also important, but it's the first step is to put efforts to work on the assignment, and that itself is valuable. It helps us. So let us go over these submissions. I noticed one pattern that some of you, when we had this question of select any two independent variables, and if you change them, what would be the effect? Describe that. So some of you have given other examples. For example, here I can see that this child has, so Santosh, you have understood that the clip itself is an independent variable. I suppose you were thinking you can replace the paper clip by some other kind of clip. And the amount of pressure that you apply, that's another variable. Only thing is it dependent or independent? We'll discuss that a little later. What I wanted to highlight was you have written in this question that the type of soda, diet, or regular is the independent variable, whereas the level of blood sugar that you measure is the dependent variable. So this is an example of independent and dependent. And we were considering this example in the previous session so that you understand what are independent variables, what are dependent. In this case, in this assignment, you were supposed to say how changing some of the independent variables of the catapult model will affect some of the dependent variables of the catapult model. For example, what Adrija has done is she has said the weight of the projectile. And when she's saying projectile, she's referring to the object that you place on the catapult and which gets thrown to some distance, right? So how heavy is that object? So weight of the projectile, if you vary that, let's say I initially put a cotton ball and then I put those iron ball bearings or a nut, I mean a metal nut. Second variable is the length of fulcrum. I suppose you are referring to the length of the ice cream stick. Fulcrum is the point where the ice cream stick is resting on the clip. So you are referring to the length of the stick, the arm of the catapult. So you can vary that. You can vary the angle, how deep. So if this is my catapult, am I launching it from here or am I launching it from here? How deep I am taking the catapult before releasing it? So these are the variables that you change. And as you do that, Adrija is saying she would observe how far the projectile is traveling. So the change in the projectile distance and how fast it is going. And in this answer, that's what she has described, that if you change the weight, then according to her, so this is her prediction that the heavy objects will not go far, lighter objects will travel more distance. And second prediction she is making is if we change the angle of release. So if we increase the angle, I suppose when you say acute angle will send things far, I suppose you mean you release it further, deeper and deeper, then it will travel more distance. So the first point I wanted to highlight is in this assignment, it was about the catapult model, not in general. Next, there are some which I've selected and I would like to hear from the children directly what was the thinking in their mind. So we'll start with Adrija. Can you unmute yourself and share? Did I understand your thought process correctly? I just used your example to explain the difference.
Yes, sir, you have.
So help me understand your thinking on the length of fulcrum. What are you referring to as length of fulcrum?
Length of fulcrum is about the angle.
Okay. So, and when you say acute angle will send things further, are you referring to taking it further down? Is that what you mean by acute angle? I think you're speaking on mute. Can you unmute and speak? Can you unmute and then speak? I'm not able to hear you. Okay. So you are saying you take the catapult further down, then you are predicting that it will travel more distance. So what's your thinking first prediction where you are saying if it's a heavier object, then it will not travel as far as a light object. What makes you make that prediction?
Light objects are smaller, and if the object is heavier than the cap, it will not go far. It will not go further.
And do you see a similar phenomenon in your daily life? What makes you predict that heavier objects will not go as far as the lighter objects?
Hear you.
I'm saying, what makes you make this prediction that heavy objects will go less far? Do you see this somewhere else in your life?
I have tried several objects, and I noted down that the heavier objects were not falling further, and the
Okay, so it
lighter
was your
objects were.
observation. Okay.
My
Okay.
lighter objects flew all across the bed.
Okay. Okay.
Currently, I'm not at my home, so I don't have some of the projects.
No problem. That's okay. I wanted to understand what all you have explored. Snidil, you have raised your hand. You can unmute yourself and speak.
Yes, sir. Sir, could we write something about the weight of the object that we are actually throwing? Like the doubt she asked similar. So is it allowed or we have to describe the structure only?
No, no. Weight of the object is one of the variables that you can change.
Yes, sir. So we can take it, right?
Yes. So what do you think
Okay,
is
sir.
the weight of the object independent variable or it's a dependent variable?
It is an independent variable.
It is the independent variable. And when you vary the weight of the object, what will be the dependent variables that you'll be looking?
The lesser range. There would be lesser range.
Yes. So
The
what will you observe? What will be the
horizontal distance
dependent
of the
variables?
objects.
What will be the dependent variables? That's my question.
Range of a projectile.
Okay. Okay, Spinel. Thank you. Anyone else who has raised hand and wants to say something? Okay, I see Bisman Kaur has raised hand.
Ditvi Singh raised her hand before.
Okay, sure. Let her. So
Ditvi, you speak first. Bisman, you can speak afterwards.
Yes,
Okay?
sir. Yes, sir. Sir, actually, this is my first bootcamp session. I've missed the last two sessions. So, what is this assignment all about? I can't understand.
Okay, that we just hold on to your question. We will be discussing further and you'll be able to understand it better. To explain it in very in a short time. So we made one activity, which is the catapult model. And this assignment was about finding out what all can you change in the catapult model. And we are looking at the assignment submissions. Okay. So
Okay.
Just hold on to your thought and stay for the session and you'll be able to understand it better. Bisman?
Yes, sir. Yes, sir. In this catapult, whenever we put a medium object, it travels further. And if we put a very light object, it will not go so far because it is very light. It will go close. And it is the same with object which is very very heavy.
Okay, so your observation is
And,
similar to.
and the object is an independent variable, and how much I pull and how much distance it is, it's the dependent variable.
And how much you pull, is that also a dependent variable?
Yes,
What does it depend on?
it depends on how much I pull the object, that far it will go.
Correct. So let's say I put heavier object. Depending
It
on
will-
how, let me finish. Depending on whether I'm putting heavy object or light object, it will travel different distance. So the distance traveled is dependent on the weight of the object, right? That's why we are calling it a dependent variable. How much you pull, does that also depend on something?
No.
So then how much you pull is not dependent on anything. And hence you would categorize it under independent. So what may happen is, so if you pull differently, accordingly will the object, the distance traveled by the object, will that also change?
Yes.
Yes. So then you have two different independent variables, but a single dependent variable. So the single dependent variable is how far it is going, but you have two different variables which you are changing. First you said you'll change the weight, second time you said how much you are pulling it down, right? The angle.
Okay.
Okay, I see, Bisman, that you have actually tried various objects, and based on that you have written. That's what I think Adrija had also done. Let me take one more example, because most of you have talked about weight and the angle at which you'll release the catapult, the angle of the arm. There was so Siddharth has captured one more variable, which is the length of the lever. So the catapult, we are fixing an ice cream stick on it. So if I make it longer or shorter, based on that is saying.
Sir, I have used a long length of a long stick, and the object have gone far away
Okay.
than the smaller catapult.
So since my video is on Spotlight, I couldn't. So it was Siddharth who just spoke, right?
Yes, sir.
Yes, Vishal.
Yes. Yeah, I can see his video now. So Siddharth, what you are saying is when you used a longer stick, then it traveled more distance. Yeah, I can see your two models also. Very nice. That was, it's
I tried with small objects, and it also traveled far away, and the heavy object traveled only short distance than the smaller one.
nice. Okay. Siddharth, thanks for sharing that. And that's a.
I tried with paper ball and a plastic ball and a rubber ball.
Very nice. Okay. Thanks for showing that, Siddharth.
I also tried this one.
Oh, okay. So instead of a paper clip, what you have used is a bunch of ice cream sticks. Around that, you have made the catapult.
I also used rubber band.
Okay. So I don't know if other children are able to see. So in fact, on the ThinkTac website itself, you'll find this other model as well. So this is another way. What Siddharth has made is, instead of using a binder clip for the catapult base, he has used around 10 ice cream sticks, and in that he has inserted the other ice cream sticks. Thanks, Siddharth, for showing those models.
Thank you, sir.
Okay. Let's take one more example, and after that we will look at actual demonstrations. So this was another interesting one because Amaira Singh, what she has said is size of bottle cap. That's another variable to vary, and based on that, the number of items that you can throw, that can vary. And the reason it could be relevant in a catapult is when you apply it in real life. In fact, let me pause here. Why don't we hear directly from her? Amira, if you are there, can you unmute and share what were you thinking?
Yes, sir. Good morning, sir.
Yes, beta.
Yes, sir. Sir,
So
the
my
size of bottle cap means we can store more of the things, like we can store a rubber ball, and many things if the size of the bottle cap is larger. But if it's small, we can't store that much of things. And length of the icing sticks. If the length is large, so it will so the things that are kept inside will the distance travel will be more. And material use, like we can use something else except the bottle cap, like a small basket or something like that, and something else except the clip.
So the question I had for you is, let's say I experiment with a paper ball and a rubber ball, the way Siddharth was showing, and I measure the distance for both. Let's say the paper ball travels 20 centimeter, and you observe that the rubber ball travels 12 centimeter. Now, in my basket, instead of putting only one of them, I put both of them. So now, will the paper ball still travel 20 centimeter? Less than that, more than that? And what will happen to the rubber ball? What do you think?
It will travel same.
Both will travel the same distance. That's your prediction. Have you done this already? Have you done this measurement?
No, sir.
Can you try it and share with us separately?
Yes, sir.
Okay.
Thank you, sir.
Okay. Thank you, madam. I was saying in real life, when they were used in wars, as I think one of you has also mentioned that in your submission. There in the catapult, if I put more number of objects, then I can throw further distance. I see that somebody is annotating. Please don't do that. I have disabled it already, but you remember that you have the option of not attending the session. So please don't disturb those who want to attend. Okay, I'm erasing this for now. And also realize that this session is getting recorded and we'll be able to find out. We don't want to do all that. If you're interested, then please attend the session and don't disturb others. Okay, coming back. So the interesting point which Amira has brought is, if you increase the number of items, then imagine in a war kind of situation, it gives an advantage to the person who is using the catapult to attack the enemy. Because now I can not only throw, let's say, stones through the catapult, if I also want to throw a few explosive items, I can throw all of that in one shot. The question I have for you is it the same amount of energy that I'm going to put in, and hence will I get the same amount of energy as an output when it gets thrown? In which case, will the distance traveled by one object separately be same as the distance traveled when I put more than one object in the basket? And that is what I requested Amira to measure and find out and share with us. I think we can start looking at some actual demonstrations, but before we do that, if there are any other thoughts that someone has, you can unmute yourself and share. I see that Bhardwaj M has also written in terms of dependency, whether it is inversely dependent or directly dependent. So that is also interesting. I just want to request that if you have been discussing with parents, siblings, etc., and using these words, make sure that you understand the meaning of those words clearly. Otherwise, it's not necessary for us to use difficult language or difficult terms. We can talk the way we understand. Okay. Lakshmi, is there any other relevant and interesting one which I may have missed?
No, Vishal, I think you covered everything, the important ones.
Yeah. Also, to all the children, I wanted to highlight. So this is another interesting example. What Darsh has said is I can change the color, let's say color of the bottle cap which I fix, or the ice cream stick, etc. And that's actually true. It is a variable. It's important for us to understand that when we are doing a scientific investigation, an experiment, then we find out what is relevant. Otherwise, many things can be changed. So if we want to understand how the catapult functions, that is how it works, for that, changing the color may not have an effect. But definitely the changing the color will have an effect on how good or how bad my catapult looks. And hence it is definitely a variable, but it may not be a variable that we would be interested in for our scientific inquiry. Okay, Lakshmi, maybe you can take it over from here.
Yeah, Vishal. Thank you. Yes. I'll just share the screen. Okay, all this while we were, discussing about what all you thought of the independent variables, dependent variables, and there was one more thing, that is the control. Maybe as just now we saw the cap part, the control variable can come into that also, because it will not affect anything. We can keep it controlled also. That can be another part. And we will just directly go into what are the independent variables which we just discussed. So can you just name one by one? The first one, you just put them in the chat box. From the discussions, what you feel in the catapult model, the independent, just to make it clear, dependent variable and independent variable. What is it? Dependent is something whose value we are observing when the independent variable is changed. So by changing what is that observation I can make? So can you name one? I'll start that. Let us say the angle. Is there a text box? Yeah. Can you name the second one? Somebody I saw in the sheet, they had mentioned length of the arm, that is the launching arm. These are all the independent variables. Are you all chatting? I mean, typing it in the message? I'm not able to see.
Yes, Lakshmi, lots of replies are coming in the
Oh,
chat.
is it?
Yeah.
Oh, okay. This was covering. I could not see that. Angle and length. Okay. Somebody is saying thickness of the stick. I just write everything, what all is coming up. Then, yes, it is the mass of the object. take it. Almost same things are coming up now. Now, by changing this, can you tell me what values I can observe? Let us say if I change the angle, what values I can observe, that becomes my dependent variable. Can you name them now? The dependent variables. See, these are independent. When I change, let us say the angle, what is that I can observe or I can measure? The range, okay. So let us say the horizontal distance. Because this is easier for us to measure. Size of the bottle cap. How will the angle and size of the bottle cap be connected? Color of the bottle cap? No. Will the angle and are they both related? Time of flight? How is that? Angle and time of flight? Again, I cannot take that. Pressure needed. Now, what I can observe, what can I measure is my question. When I'm changing the angle of the catapult, what is that I can measure? One is the horizontal speed of the ball. Okay, let me take that, but to measure that will be difficult in this setup. Maybe we should have a different thing to make a note of that. Of course, the other one is the vertical distance, which will be little, as you said, the height. This will be little difficult to, but we can observe this, measure as such. Okay, let us go with any one of them and give your predictions now. Now, let us say I am keeping the angle. Let me just draw that. Release angle, where is that here? Let us say this is the catapult model, and I want you to tell me whether this catapult or I'm drawing one more. Now, can you tell me out of between these two, one I'm keeping at this angle, another one I'm pressing more. So which one do you think will go far? Did I tell you about the object? Which object I'm using? Will that also matter? Asha, you can just allow them to unmute and let them speak up. I can't. Yes, Bisman, can you tell me?
Just give me 1 minute.
Yeah, sure.
The wider one will take the most, will make the object go more distance, because then you can put more pressure.
Sorry, Bisman, your voice is not so clear. Tell me.
The wider one, because when you put pressure, that can put more pressure than the other one.
No, I want you to talk in terms of the horizontal distance. Now I'm changing the angle. What is the distance it will cover? Whether the object, let us say I'm using a, say I'll just show you that. This chana, have you all seen this? I'm just using this chana. Okay. This is the object I want to throw in using these two catapults. I want to see which one travels, far. Horizontal distance, where is it covered more or less? is it in this part or this part? Yes, Aradhya?
The first one.
So the first one you say will cover more distance. Okay, that's good. Let's see. Aradhya, you have something to say?
Yes, ma'am. Ma'am, the second model will go far because we are giving more pressure than the first model, and the object is also light.
Object is also light. Okay, we'll keep this aside. This is one. Now I'm just going to the second part. Okay, here what I'm doing, I'm just sorry. So I'm just increasing the arm length now. Compared to this, which one will throw far? Let us say I'm keeping the same angle. Angle I'm not changing. I'm changing only one of the variables. Okay, that is the length of the arm. And again, I'm keeping this also constant, same object. Now, can you tell me whether the shorter length arm will throw far or the longer length?
Longer length.
Longer length, okay.
And the longer length.
Okay, now I have another one. Between these two, I'm using this. Can you all see this? Cotton wool.
Yes, ma'am.
Yeah.
Yes, ma'am.
Just tell me between these two, which one will be able to make this cotton wool cover more distance, horizontal distance? Which of the two catapults should I be using to cover more distance? Let it put it like that. Which one do you think I should be using out of these two catapults to make this cotton wool travel more distance?
And third one.
Sorry? Third one, where is the third one?
Longer.
Okay, this one, you say
From the
this one?
second catapult.
Second catapult.
And longer one.
Okay.
And the longer one. And the longer one.
Okay.
One second catapult.
Okay. I'll just stop my share now. And I'll show you my catapults. Can you see this here?
Yes, ma'am.
Ready for launching? Can you all see this?
Yes, ma'am.
It starts. I have just used the second option, that is
Yes,
the
ma'am.
length of the arm. So I have had, see, I've used different colors. Color doesn't matter. Okay, the length is different. Short, this is little bigger than this. This is little more bigger. And this is, see the height here. So this is also more. So I just have to keep like this and same angle I have to release. I think this we can watch the video because it will be difficult to show the entire thing here. And you all can see whatever you predicted, what was the actual observations. Is this visible now, Ashray?
Yes, ma'am.
Yes, Lakshmi, it's visible.
Yes, ma'am.
See, I'm using the cotton wool. Same angle.
This is more shorter.
You saw the difference?
Ma'am, as we are giving more pressure.
No, it's the same thing. Let's not go into that because I just concentrated on the angle part. Now, can you tell me what we observed with the shorter arm length and when compared to the longer length? What is your observation? Adrija, you would like to say?
Amira Singh and Siddharth PS have raised their hand.
Yeah,
Amira, you can go
please
first.
tell me.
Ma'am, the longer length is going far. Ma'am, in the longer one, we will
The longer length is covering more distance, right?
Distance is dependent on the height. Length is different. Length is different.
Length is different, I know, but now tell me whether the longer arm, the launching arm, okay? The catapult arm.
Distance is dependent on height, and the pressure is also. Ma'am, the longest one put the longest. Ma'am. Longer arm. Ma'am, is long. It puts more force and it will go far.
The longer length can go far. Okay. So here we kept the, what are the things we kept constant here?
Distance dependent on the height.
Dependent on the height. See, I told you height is also there, but that will be little difficult to measure. In this case, what I showed you, the video.
difference
Please.
Length of stick.
Ashray, somebody is talking with their mic on. Keep, mute them, please. Yeah. See, I was telling you in this setup, what I showed you, the video, what was the independent variable I had changed? Can you tell me that? The independent variable which I had changed, that was the length, right? So length was changed, and what was to be observed? Only the distance. What other things I kept it constant? That is, I controlled it. I didn't, make that as also being hindering this launching part. So what I kept constant was the launching angle, at what angle I'm launching, and the same object, so that I don't get two variables being changed at the same time. Like I'm changing the angle, I'm using a different object, then again I get two different results. So here I want to see what effect does the changing of the arm length has on the object. So object also was same. So when the object was same, we saw that the longer length arm will cover more distance. So there are so many options which you can try out with the same setup. You can use, as you said, so many things, like see the paper ball you can use, and I just have this thread with me, this ball of thread. Then as you said, this is a little hard ball, and then the I have a smaller one, that is the, this is a very small, some plastic item. All this you can try out. That again depends on, everything. You have to make a note of that, observe it, and see what exactly is happening. So yes, Adrija, you have anything? Siddharth, sorry, Siddharth, tell me. Tell me, Siddharth.
Ma'am, I tried the longer the arm, and it the object has gone far distance.
Correct, Siddharth. That's what we also saw, and that was very nice that you have tried that.
And I tried with different objects. The lighter object had gone far away, and the heavier object has gone shorter distance.
Correct. See, that also there are so many things which come into picture with the lighter object and the heavier object, but we'll just keep it simple. We will just observe that the lighter object, what we use.
Changed the clip, and I have used the.
Yes, Siddharth, I saw that. You were showing it to Vishal sir, and I saw that. That's very nice. See, if you can just imagine your arm itself as the catapult arm, and if you have a ball in your hand and you're not, going like this, you're just holding like this and throwing. Do you think the ball will go far? Just imagine you're having a ball in your hand like this, and I'm not moving much.
No.
But if I go like this, maybe.
Will be go fast distance.
So similar to that is something what we did now, changing the length of the arm. Maybe you can try out with the Arshi. You have something Tell me, Arshi.
Ma'am, I want to say that ma'am, here the independent ma'am, please wait.
Bhavya.
Ma'am, the distance is
Huh?
dependent on the length of the ice cream stick.
Yes, that's what we observed, right?
Yes,
Tell me,
ma'am.
Arshi.
Ma'am, I observed that ma'am, here the independent things are like we can use disposal spoons in the place of the ice cream sticks and
That comes under the physical part, physical part. But is
yes,
it hampering the distance covered? That you have to observe. So when we talk about independent variable, by changing something, I'm observing some other thing. So that is my dependent variable. So I'm not worried about the ice cream stick or the cap or the spoon. What am I concentrating? If I use a bigger spoon, that also will give me a far distance, cover longer distance.
ma'am, and here the dependent things are like ma'am, I observed that if we use the bigger length things, so we get that far. If we
Yes.
do something by the help of the bigger things, it will go far.
See, as you all said, if I go on pulling it back, do you think it will go far? That I want you all to try it out. Let us say this is the model, right? So if I go on pulling like this, totally. Now, do you think the cotton wool will travel faster, far distance, or at this position or at this position? That I leave it to you to try out and make a note of that. Okay. So this only one I showed was the length of the arm, meaning that what we observed, the longer length arm and the object being same, it covers more distance. Is that okay? Is that clear?
Yes, ma'am.
Yeah. Ashray, will you be showing those next part now? Any other questions in this? If you
Just
have
give me
any
2 minutes, Lakshmi.
yeah, sure. If you have anything else, please, Adrija, you have anything? If you don't have anything, please lower your hand so that you don't get confused. Now,
Advik,
Ashray,
you can unmute yourself if you want. I've given you the option.
yeah. Advik, you have something to say?
Ma'am,
Yes, Tejasveer.
I'm in the catapult model.
Huh?
When I catapult model, when I put a thermocol and the eraser, so when I threw it, so the thermocol not go far and the eraser go far. Why? Eraser is thicker than the thermocol.
What is happening to the thermocol? You think of the feather. Have you seen the feather?
Yes, ma'am.
You imagine this is the paper ball and you have feather in one hand, or maybe this ball, this rubber ball and the feather. Which one will come down fast?
Ball.
Ball, right? So which is having more opposition? The feather is taking time to come down, right? It is light. Something is also pushing the feather, right? It is not allowing that to come down. You think of that, what is it that the feather is experiencing before it reaches? Same thing is happening when your catapult is being launched. When the ball is going, that is different. When the paper ball, this is different. You try keeping a feather on your launching pad and then try to launch it and see what happens.
Okay, ma'am.
Is that clear?
Ma'am,
Yes,
uh,
Bharadwaj.
instead of binder clip, we can also use string also.
Ma'am, I used eraser. It go far away.
Huh?
Ma'am, I
From the first
cotton's ball.
distance, ma'am.
What is that? Rupa, is it your name?
No, ma'am, I'm Charvi.
Charvi, tell me, Charvi.
Ma'am, I used eraser.
Hmm?
From the first distance, go far away compared to the other.
See, I'm not able to understand, Charvi. Can you show the model? Can you show the model? Which one you used and
Ma'am,
eraser
I
was
used
launched?
eraser, ma'am.
Where is your catapult model?
What, ma'am?
Your catapult model?
No, ma'am, I didn't do.
You didn't do?
Hmm.
Then, okay. Try making that
By,
and
by using a hand, my hand.
using hand, you threw the eraser, is it?
By using clip, ma'am.
Okay.
I throw like that. Let's
Okay.
go far.
It is going far, is it?
In the clip, ma'am, I take eraser.
Hmm. See, it becomes difficult to launch, no, Charvi? You try out the model what we have shown. In that, you try placing the eraser. And as Tejasveer said, you keep a lighter object. Maybe if you can get hold of a feather near your place, try placing that and then see which one covers more distance. Okay?
Okay, ma'am.
Anything else? Aradhya?
Ma'am,
Yes.
the model depends on the length of the stick and the weight of the ball, no?
Yeah, I didn't use the ball because I didn't want to change two things. No, if I change two things, then again I will get confused. What exactly is what I have to observe? So you should not be changing two things. So only one thing when you change, and you have to observe what is that change causing the dependent variable to act. So if I change, see for example, if I have this, this is the model. I should use only this model. The length is fixed now. Angle also, let us say I'm going to press only half and use different objects. And then that is, what is that I'm changing? I'm keeping the length constant. Objects are changed now. Angle also constant. I cannot do two objects, same length. I use different angles. Then you'll be getting confusing readings. So when you want to make a note of actual observations, you have to change one variable. So let us say I'm changing only the objects. So with the same model, arm length is this much. And what is that? I get to see.
And ma'am, if on the model I use the lighter object, then it will not go far, no? If I change the angle.
Yes, that also I just told them the two examples, feather and the rubber ball. Okay.
Because the feather is lighter, so it is pushed by the air.
Yeah, that is again a different concept, Aradhya. So that has so many other things, factors affecting that. So definitely the distance traveled will matter.
Okay, ma'am.
Okay. So for the time being, we'll just see the independent variables in this model. What we saw was the angle, the length, and the mass of the object. So when I change any one of them, keeping the other two constant, what is that I'm observing? That observation is in terms of the horizontal distance. I'm keeping the angle same, the length same, different objects. Now object is same, length is varied, angle also same. You get the distance covered. So all these three options, you please try out and make a note of that. Is that clear? Shall we move on to the next part?
Sorry, Lakshmi, just 1 minute. Adrija, do you have a question, or do you, your hand is raised
No,
right
it's
now?
just raised.
Adrija Upadhyay?
No.
Okay.
Ma'am,
Yes, Adrija?
ma'am, if the thing we put in the catapult is heavy, it will not go a further way.
Yeah, that also again depends, there are so many other factors binding that. So I may be able, see, can I throw a 100 kg ball? Can you throw that? So each one or the model has that limitations also. So for this model, what is that I can try out? At the most, I can keep this rubber ball. So if we try to understand to this level, maybe that will get some information for us and we will be able to understand. In this, definitely, as you said, I cannot be keeping a very heavy shot put ball, here. My model only will break. Can I do that? As you said, as that becomes more and more, so the capacity of this also has to increase so that that is able to throw. You may not be able to throw an iron ball of this size. Maybe your elder sister might be able to do that.
Angle also depends. If it's a 90 degree, it will just fall right.
That's what I told you. Change the angle and change and see. Okay, I just showed only one variable, that is changing the length of the arm and the distance covered. Now you have two options, that is changing the different objects and the angle of the launching arm. I mean, keep the same catapult. In the same catapult, you keep changing the angle and see the distance covered. Is that clear, Adija? Is that clear, Adija? Can we move on to the next part?
She's saying yes, Lakshmi.
I cannot hear you.
Yeah. We'll move on to the next part, Ashray. I think you can start now.
Okay, Lakshmi, just
This
give
is
me 1
very
minute.
interesting, and please make a note of this, and you'll have to be very interactive and make a note of whatever he's showing. This is very important for tomorrow's assignment. So tomorrow's assignment, again, I'll be pasting the link and he will tell you what all has to be done. Over to you, Ashray.
Yes, Lakshmi. Guys, just give me 1 minute. Okay, so what I'm going to be doing now is I will be sharing my screen and we'll be watching some videos of some TACtivity, some models. And in the chat, you guys tell me which do you think are the dependent variables and which do you think are the independent variables. Okay, I'll repeat that again. I'm going to show you all a couple of videos of some new models, some TACtivities. In the chat, tell me which one are the dependent variables and which one are the independent variables. Just let me share my screen 1 minute. Okay, so I'm gonna play this video. Lakshmi, are y'all able to hear the sound? Lakshmi?
Yes, Ashray.
Yeah? Okay, I'll continue.
Yeah.
Now in the chat, I want you guys to write what do you think are the independent variables in this model and which are the dependent variables. If you want to be reminded again, independent variables are the ones that you change, and dependent variables are the ones that are affected by the change. Size of ice cream stick. Naksh, you said length of what? Bisman says length of thread. Okay, yes. Is the length of the thread an independent or dependent variable? Okay, let's do one thing. Why don't you all write down what you all think are the independent variables here? The ones that you can change, all the independent variables. Length of thread, okay. Length of thread is one independent variable, which is the other independent variable. Okay, Kara, you're saying the thing we draw, does that have any effect on the model? Does the thing that we draw have any effect on the model? Think about that. Bisman Kaur says stick size. Okay. Think again, does the size of the stick does the length of the ice cream stick have an effect on our model? What are other things that are present in this model? Position of tie. Okay. Can use wool instead of thread. Okay. Does that have any effect on our model? So one thing that I see everybody is missing. Do you all remember this part of the model? Do you all remember this part of the model? There is an independent variable here. Can you all figure out what the independent variable here is? Weight of what, Dhruv? You're saying weight. Weight of what? Bisman Kaur says straw. Tejasveer also says straw. So is it only the straw that's the independent variable? Naksh, joining point. Joining point of what, Naksh? Think. What all are the things that we can change here that might affect the affect whether this thread climber can move up or down? Yes, Pranil, you got it right. How the straws are inclined. The angle between the two straws is another independent variable. The angle between the two straws are another independent variable. If we change this angle, that will affect how, or actually whether, our thread climber will actually climb up the thread or not. So far, we know two independent variables. One is length of the thread. You guys were right about that. And the second one is the angle between the two straws. That's your two independent variables. And our dependent variable is what over here? Whether or not the straw will climb or not. Okay. Kushal, length of distance, both mean the same thing. Both are measuring the same thing. So I don't know what length of distance is supposed to mean. Okay, so I will move on to the second video. This one is on chromatography. Chromatography is basically separation of colors, and we're going to see a very interesting way in how colors can be separated. So just give me 1 second. So some of y'all have mentioned that, you know, the animal that we draw, the butterfly, honestly, how does that affect the model? It's just a picture we're pasting on the model, right? Does it genuinely affect anything? Does it affect whether the thread climber will actually climb up the thread or no? We can do this model without the butterfly, right? Think about it. We can do this model without the butterfly. Okay, so I will play the chromatography video, and then once this video is done, I'll ask you guys for what you all think are the independent and dependent variables. I think this was very fast. I'll play the video again and then we can discuss. So they're taking 5 colors and putting them around a hole in the filter paper. Purple, yellow, blue, sky blue, and green. Then this person is folding a tissue paper and passing the tip of the tissue paper through the tiny hole that he made. Then he places the tissue paper in water so that water gets absorbed and soaks through the tissue paper and reaches the filter paper. Then the water in the that comes out through the tissue paper reaches the filter paper and starts separating the colors. So what do we see here? We see that the green dot that we had made is now separated into yellow and blue. So this is what chromatography means. It's the separation of colors. So I want you guys to, in the chat, tell me what are the independent variables in this setup. The kind of paper, concentration of colors, the glass distance. Sorry, this is moving too fast. We can use a paper instead of tissue. Okay. Colors, yes, colors are an independent variable. Increase the water level. How does that matter? Because water is anyways, getting soaked by the tissue and reaching the filter paper. Size of the dots, okay. Length of the tissue, okay. Size of the filter paper, okay. So remember that the point of chromatography is that you are able to separate colors when colors are mixed. So think along those lines and think of what are the independent and dependent variables in this setup. Yes, Advait, you're right. Colors are an independent variable. If the water is too low, it will not go up. Okay, is it about water not going up, or the amount of water? Is enough water present for it to, spread across both the tissue paper and the filter paper? Okay. Solvent. So what do you mean by solvent? We're not using any solvent here. Yes, water is a solvent, but that doesn't matter here. Density of dots. Dhruv, what do you mean by that? Okay, so what we can choose in this particular model is the colors. We can choose which colors we want to see, whether they are mixed colors or they're, how do you put it, pure colors, or if any other colors are used to make that color. That's what this model, this setup, this experiment can help us find out. So our independent variables are, we can choose the colors. Our dependent variable is, whether a color gets separated or not. Do we see separation in a color or no? That is our dependent variable. So we choose the color, and whether we see separation or no, that is the dependent variable. Okay. So I'll move on to the third and final video. Just give me a second. Glucon-D. Dhruv, what do you mean by Glucon-D? Why would you put Glucon-D into this at all? Glucon-D will have no effect. So this video is about anaerobic respiration. So what anaerobic respiration means is breathing without oxygen. So when we breathe, we use oxygen to we inhale oxygen, right? Ours is aerobic respiration. In anaerobic respiration, oxygen is not present in this experiment. Okay, I think I'll stop here because the recipe experiment is a little bit of a higher level science. Okay, so what did they do here in this experiment? How many of you guys, just let me know in the chat, how many of you guys have ever baked a cake? Have you all ever baked a cake? Just let me know in the chat if you've baked. Ajija says yes. So when you're baking, Samita also says yes. Dhruv also says yes. So when you're baking cakes, do you all add yeast to your flour? To your, right? You add yeast that added in, what do you say, in this in this experiment. So while baking cakes, we also add sugar, right? So the yeast begins to sort of break down the sugar, and it's those tiny bubbles that we see in cakes. The reason why cake batter rises, we keep it in the oven and it rises. It's because the anaerobic respiration is taking place. The yeast is breaking down the sugar, and it's creating small bubbles of carbon dioxide. That's why when you cut a cake, you see those tiny holes, and it's very spongy and soft, and you can squish it and all of that. So yeah, so here similar thing is happening, except instead of adding that to cake batter, we're adding it into just a plastic bottle with water and sugar. We're adding yeast just to a plastic bottle with water and sugar. And then we're capturing all of the carbon dioxide that this reaction produces. So now in this situation, what I want you guys to write down in the chat is which of these are independent variables and which of these are dependent variables. Oh, one more thing I forgot to mention. So at the end of this experiment, we remove the balloon, and then we measure its volume by pushing it in water. So thinking about these things, what are the independent variables and what are the dependent variables? Write down in the chat, independent dash, these are the independent variables that you think, and dependent dash, these are what you think are the dependent variables. So let's see what you guys have written. I will just go out here and stop sharing my screen for now. Okay. Adrija says independent variable gas inside the balloon. Are you sure? Dhruv Babbar says independent is size of balloon. Okay. Siddharth, is yeast a dependent or independent variable? Adrija, dependent variable floating. Okay. Okay, so Darsh Asnani, sorry, I missed that. Darsh Asnani says independent variables are sugar and yeast amount. Correct. Those two are your independent variables. Those two are things that you can control. You can change the amount of sugar that you put into the bottle. You can change the amount of yeast that you put into the bottle. Those two are your independent variables. Oh, Darsh, you said dependent is gas. Just gas? Is gas the only thing that's your dependent variable? Independent yeast can be replaced by baking soda. Okay. That is also an independent variable. Yes. Temperature also. Is temperature a dependent or independent variable, Aditya? Okay, you said independent. Okay, okay, correct. What are your dependent variables now? Can you all tell me what the dependent variables are? So we know that yeast and the amount of water are your independent variables. What are the dependent variables? Ditwi Singh, dependent variable is volume of balloon. You're correct. Your dependent variable is depending on how much yeast and sugar and water you put into the bottle, that will tell you how much gas can form in a balloon. Dash, I'm not sure the size of the balloon really matters unless you put like a really tiny balloon and there's just too much gas in the balloon bursts. But the amount of gas that is generated from us, like if you choose say 5 grams of yeast and 5 grams of sugar and say 50 ml water, like you will get a certain amount of gas released, and that will not change depending on the balloon. So no, your balloon is not a dependent variable. But yes, the volume of the gas is a dependent variable because it depends on your amount of water, amount of yeast, and amount of sugar. Okay, so these are the three models that we have seen, and we try to figure out in these three models which are the dependent and independent variables. So I'll hand it over to Lakshmi now. Lakshmi.
Yeah, Shray.
Yes, Lakshmi, I'm done.
Yeah, I think Shivani will be explaining the submission part. It's the video submission, no? For tomorrow, what they have to do. Can you do that?
I can do that.
Yeah,
Okay.
just explain them the assignment for tomorrow, and I'll be pasting the link.
Okay. So the assignment for tomorrow is you can make a model of your own, anything, a model of your own, and you need to change two independent variables and check how the dependent variable changes when you change your two independent variables. And you need to record a 5-minute video and send it on this form. Shivani has just posted this link on the chat. If you're searching for the link is available on the chat. It will also be available on the WhatsApp group.
Already posted there.
Oh, okay. The link is already posted on the WhatsApp group. Shivani has just posted the link on the chat. On this link, you have to send a 5-minute video of any model that you have created. You need to change two independent variables and see how it affects the dependent variables. Do you all have any questions? I'll just
share and show them what exactly is that.
Okay, Lakshmi. I'll just remove my spotlight.
See, when you go to YouTube, you have this. What is this? See, you have this button here. The video plus. So when you click on that, you get upload video. So there you have to click and may upload your video. And whatever link you get after that, that needs to be pasted in the form what you have received now. Tomorrow also we have the class, and it's next week also we have for 4 more days. Okay, Monday to Thursday we'll be having. So tomorrow will be the last part of the innovation of this week. So did you all understand what to do? You have to make one 5-minute video. Okay, not more than that. It should not be a lengthy one, because this is all what we are trying is practicing for the actual Raman Awards. So this is just a practice for you to make a short video, upload it on the YouTube, take that link and paste it in this form. When you click on the form, you will have an option to paste the link of that YouTube. Okay, is that clear? If you have any questions, please ask. Yes, tell me, Pranil.
Yes, ma'am. Any model will do that.
Anything.
Right.
All this, what you have to do is you have to talk about the independent, dependent variable. We want to know how well you have understood, and you have to show it to us.
Ma'am, if there is no change in the independent variable.
No change in the means?
Well, obviously the independent variable is independent, right? You need to see what change happens in the dependent variable. You need to change two independent variables and see how they affect the dependent variables.
Okay, sir.
Prithvi, did you understand what we did today?
Yes, ma'am.
Okay. So you should be able to make the video, I guess. And for all the previous sessions, we have put that in the chat box. So, I mean, in the WhatsApp group. So please go through the links if you want to have a look at what happened yesterday. And
Yes,
Dhruv, do you have anything?
Yes, ma'am. I wanted to ask how long should the video be?
Less than 5 minutes.
Okay, ma'am. Thank you.
Anything, Siddharth, anything which you like to explain, and it should be less than 5 minutes. You should be explaining this independent, dependent. When you change this, what is that you're observing? All this needs to be shown in that 5-minute video.
Okay, ma'am.
Okay, you can make use of the ones which you have already made now in these 2 days.
Okay, ma'am.
Even that you can use and send it to us. So you have to submit it before tomorrow, before we start this session. Is that clear? Yes, Arshi. Thank you, Siddharth.
Ma'am, I want to ask that, ma'am, I want to tell that, ma'am, I am not at my home, I am outside.
That's left to you, Arshi. If you want to try out with some things available, because we like to encourage doing things with whatever is available, not stick to one particular thing. That also is a creativity, right? So think what all you can do, like we did 2 models, right? If you can do with the available things at home, then definitely I would encourage you to try that and submit a video. You can say that in the video as well, that I don't have the model, but what I've understood is this. By changing this, this happens. Changing that, this happens. So you can just explain that also, just to get a feeling as to how it will come. Okay. Don't always think of no. Start with the yes. Yes, Galaxy J4, nice name. Tell me, Galaxy.
Ma'am, we should share the video at YouTube.
You have to upload on the YouTube, and on the YouTube you get the link, right? Copy
Yes,
that and paste it in the form which we have shared now.
Okay.
Yesterday also you got one form, right? You
Yes, ma'am.
clicked and entered in that. Same way, when you click on the form, you have to paste the link. That's all.
Okay.
But that link is the YouTube video which you have created and uploaded there.
Okay.
Is that clear? Shall we end the session? Wait, 1 second. Parnika, tell me, Parnika.
Ma'am, how many independent and dependent variables to be
At least 2. If you can make out more, it's good.
Ma'am, so 2 independent variables and 2 dependent variables?
Yeah, when you change those independent variable, what is happening to the dependent? You have to show that.
Okay, ma'am.
So Arshi, I think I answered your question. Anything is there? Lower your hand if nothing is there, please. Dhruv, tell me.
Yes, ma'am. I have another question, which is I arrive school. So, ma'am, I have school, and ma'am, I arrive home at 1:30. So, how am I going to do this?
See, doing you can do now, and you can put the video. That is possible. You can join the session little late. Is it
Yes,
okay?
ma'am.
So don't always think no. Try to make way for these things. Then only you'll
Yeah,
enjoy. Thank you. Yes, Kyra.
Okay, ma'am. Bye.
Yes, ma'am. I would like to ask that in the 5-minute video, so what do we exactly have to tell about our model?
See, if you have anything on your mind already, like some experiment which you had tried out previously, and you have that on mind, you can use that. And in that, you have to focus on talking about the independent variable and the dependent variable. You have understood, right? In these 3 days, you have got to know what are dependent, what are independent variables.
Yes,
so if
ma'am.
you can talk about that in the model which you have selected, or if you don't get anything on mind, at least whatever we have done in these 2 days, you can pick any one of them out of, in that you can explain in a video.
Like, for example, my catapult model or the water spray.
Yes, you can do that also. In that, you have to talk about the independent variable. When you are changing that independent variable, what is happening to the dependent variable is what you have to explain in the video. And you have to show that. It should be a demonstration, okay? Not just theory part. Sorry, I just wanted to lower the hand. Charvi, do you have anything? Shall we end the session?